This is problem 1.6.1, and we're doing a Bayes theorem problem where it tells us that 1% of our population has a certain disease. Now, if you take the blood test, that has a 97% chance of identifying the disease if you have it. And the blood test has a 6% chance of identifying the disease if you don't have it. Okay, because we know, again, these tests aren't always right, and so we can get these false negatives, which is what throws off our results. Before you even look at what you're supposed to be doing, I like to go through and write out in symbols what they've actually told me here. So 1% has the disease. I would say that's the probability of disease equals 1% or 0.01. And then it says the blood test has a 97% chance of identifying disease if you have it. So I would write that's the probability that you get a positive if you have the disease equals 0.97. And the probability has a 6% chance of identifying the disease, so probability that you get a positive if you don't have it. So we'll say not diseased equals 0.06. So this means we had some kind of setup where you either have the disease or you don't. And then once you either have the disease or not, you can either get a positive test result or a negative test result. And if you don't have the disease, you can either have a positive or a negative. Now let's write on here what they gave us. Probability of disease is 0.01. Probability of positive if you have the disease means it's this branch is 0.97. And probability of a positive if you don't have the disease, so not disease and positive. Sorry, I said an and, but I mean conditional. So positive if you don't have the disease is 0.06. At this point, it's really easy to figure out the missing spots. So if this is 0.01, this branch has to be 0.99 because they all add up to 1. And if this branch is 0.97, this one has to be 0.03 because these two have to add up to 1. And if this is 0.96 and this is 0.94 because these two branches have to add up to 1. At this point, I still haven't even looked at what they've said. I've just been writing out what they told me through the picture. Now, let's look at part A. Part A says, what is the probability that a person will have a positive test result? So we're looking for the overall probability for positive. So what you're going to want to do for this is we're going to want to find the probability of all of the intersections. So let's find the probability of disease and positive. And the way you find the probability of the intersections is you multiply along the branches. So this is going to be 0.01 times 0.97, which gives me 0.0097. This one will be probability of disease and negative, which is 0.01 times 0.03, which is 0.0003. Probability of not diseased and positive is 0.99 times 0.06, which gives me 0.0594. Now at this point you might be wondering something like, why do I have to do this? Why am I changing to this 0.094 and not just going with the 0.096? So remember, this 0.06 is the probability that you get a positive if you know you're not diseased. This probability is now of all of the people, how many of them are not diseased and they get a positive test result out of all of the people, which is 0.0594. And finally, probability of not diseased and negative equals 0.99 times 0.94, or 0.9306. Now you might not need all of these probabilities, but it's just kind of easier to go ahead and do them all now. So again, now back to part A, now that we've done all this intermediate work, which was quite a bit of intermediate work, if you want to find the probability of positive, take all of the probabilities that have a positive in them and add them up. So 0.0097 plus 0.0594 is 0.0691. And so that's our final answer for the probability of a positive test result. Out of everyone in the population, 0.0691 of them should have a positive result. People that do have the disease, people that don't, just all together about 6.91% will have a positive test result. Just in case you wanted to know it, for our calculation, the probability of a positive was equal to the probability of a positive and disease plus probability of positive and not disease. So if you're following along the solutions manual, they're just going to put this formula out there. I prefer kind of using my tree diagram and going through it logically instead of trying to write out what formula might I need. So that was part A. Now let's try B. B says if your blood test is positive, so if it's positive, that means it goes here in the if position, then what is the chance that you have the disease? So we're looking for the probability that you actually have the disease if you get a positive test result, which is a good thing to know, right? Because if you go to the doctor and get a positive test result, you want to know what's the chance you have the disease. So for this, we go through and say, well, that's a conditional probability. What's our formula for conditional probabilities? That is, you do the probability of the intersection divided by the probability of what's given, which is nice because we just found that in part A. You'll notice I switched between using a D for disease or DIS for disease. It doesn't really matter, just whatever helps you remember what you're talking about. So probability of disease and positive. So disease and positive here for my 0.0097. So let's put that on the top. And divide by probability of our positive, which is 0.0691. This gives me 1403. Finally, for C, if your blood test is negative, what's the chance that you do not have the disease? So it says, okay, if you get a negative test result, what's the chance that you do not have disease? Okay. So we'll do the same kind of setup. So let's look at probability of the intersection. So not disease and negative, divided by the probability of what you're given. So let's come up here to not diseased and negative. So it's useful we found all of these probabilities, even though we thought we might not use them all. So not diseased and negative is here at 0.9306. So 0.9306. Now I didn't find the probability of a negative yet. Okay. Now probability of a negative is going to be 1 minus probability of positive. So 1 minus 0.0691. Or if you wish, you can come up here and find everything that has a negative, so 0.9306 and 0.0003, and add them together. Either way, you're going to get the same answer. So this is 0.9306 divided by Sorry, I don't know where we cut off there. I keep accidentally pausing and resuming when I don't mean to. So I'll just go through this again real quick. So probability of not disease, if you know you have a negative test result, you do the intersection over probability of negative. And the intersection, just looking up above, was 0.9306. Probability of a negative, you come back up, circle everything with a negative in it, and add those together. So probability of negative is 0.9309. Divide, and here's your final answer.